Alright, so let's now continue. So can you guys see my screen now?
Yes, sir.
Alright, that's good. Alright, so okay. So let's go on to the summary of the positive clamper with positive biasing voltage. So let's analyze it step by step. So during the negative half cycle, so as you can see, we have two possible way to solve it. So you must compare the reference voltage or the bias voltage to our voltage input. So during the V sub R is greater than V sub I, capacitor is charged by V sub R. So take a look on this one first. So will it be able to pass through this diode? So if that's the case, then that it will be able to be charged by our reference voltage or bias voltage. So positive is connected to positive and the negative is connected to the negative. So yeah, this one will become forward bias during that kind of scenario wherein V sub R is greater than V sub I. So how did that happen? Let me just give you a short demo. Okay. So as we all know, our V sub I is an AC voltage, right? And then this reference voltage is a DC voltage. Okay. So it's a DC voltage. So an AC voltage is an alternating current wherein it start from, or it always start actually from zero to positive and then uh, zero to negative and so on and so forth. Okay. So it's varying from time to time. So it's changing from time to time. Unlike the DC, it is a constant voltage. Okay. So as you can see, V sub R is a constant 5 volts. So there are times wherein V sub R is greater than V sub I. So what is that part? In this case, V sub R is greater during 0 to positive 4 volts of V sub I. Okay? Because as you can see, this is let's say 0, 1, 2, 3, 4 before it reach the peak voltage which is positive 5. So during that part, so V sub R is greater than V sub I. So that is why at that time, okay, our V sub R is completely dominating this loop. All right. And then at the time, up to the maximum voltage of this one, up to 5 volts, let's say whatever is the uh, this one value of this reference voltage, and then that will be the value of your capacitor. So as you can see right here, it will be positively charged coming from this side, positively charged, and then it will be discharged negatively. Okay, so we have a sign of negative here and then positive here. And then once now it reach this point, let's say, uh, just an example, okay, we have a V sub I, a value of 10 volts, and then V sub R is still 5 volts. Okay, so at a point wherein V sub I is greater than V sub R. Okay, so what is that at that point? What is that exact moment that we could say that V sub I is greater than V sub R? So that is during, okay, 6 volts is now greater than 5 volts, or going up. Okay, 6, 7, 8, 9, 10. So if that's the case, then this capacitor now will be charged uh, positively right here, and then it will be discharged negatively, right? So as you can see, they have two different side. Okay, so positive here, negative here, and then positive here. Ah, actually they are the same. So they collided at the same time, wherein they have the same signage. So let me just give you a circuit here, capacitor, and then the voltage. Okay, so let's say V sub R is greater than V sub I. Okay, so this one will be positively charged and then negatively discharged. That is during V sub r is greater than V sub I. But during V sub I greater than V sub r, so this will now be charged by V sub I. So positive, they are not the same. Sorry. So let's see. Yeah, they are not the same during the positive half cycle, but they will now become the same during the negative half cycle, right? So again, we always start wherein we'll be having a closed loop, okay? And then we'll be having a closed loop only if this one is a negative half cycle. So negative is connected to the negative, and then positive is connected to the positive, okay? So let's change this one into a negative half cycle for now, since my explanation before started from positive, but I made a wrong assumption wherein we've started in positive, but we should start in negative because again, we're looking for a closed loop wherein it will be charged by our V sub I, because as always, our V sub I is greater than V sub R. But there are also some cases, but it's not really a clamper anymore because our main source of voltage should be coming from V sub I, not the reference voltage or the bias voltage. So this is just, to modify our V sub I. Okay. So this one will not become or will not become our voltage source. So as always, this is the main voltage source of our circuit, P sub I. Okay. All right, so let's go back here wherein we have negative and then positive. So as you can see, once P sub I is greater than V sub R, so it will be negatively charged and then it will be positively discharged. So as you can see, we have two the same signs. So if you're going to take a look on this one, during V sub I is greater than V sub R, if you're going to calculate for VMC, VI now is will be added to our V sub R, or VI plus VR. Okay, that is the value of our VMC, okay, or the maximum voltage of the capacitor. And then during negative half cycle, our V sub O is equal to V sub R. So why? Because we have a closed loop here, and then the only voltage that is passing our V sub O is this V sub R. Or should we say that whatever is the voltage across this one is the same on the entire uh, circuit, because that's the concept of a parallel circuit. Okay, so our voltage here will be equal to V sub O. Okay? So just apply Ohm's law. That's the basic knowledge when it comes to getting the voltage output of this entire circuit. And then during the positive half cycle, okay, so during V sub R is greater than V sub I, so capacitor now is being discharged and diode is now open circuit. Okay, oops, I think this one is opposite. Positive, wait, let me just analyze this one. Positive to negative, and then positive to negative. So we will not, wait. So if it's positive, this one will become an open circuit. And the only time that it will be discharged is if we have a higher V sub I. So V sub I should be greater than V sub R. Okay. So we have a correction here. So it should be the other way around. So during V sub I is greater than V sub R. Okay. And then if you can see, positive is connected to the negative and then negative is connected to the positive. So if that's the case, then that's the time that we'll be having an open circuit here. So again, if we have an open circuit, then that's the time that our capacitor will discharge its voltage. Okay. So if we have positive here and then negative here, we also have here negative and then positive. So minus V sub R, what happened? VMC is equal to V sub I plus V sub R. So wait, let me just to check whether this one is correct. Let's analyze step by step. All right. So positive, negative. This is P sub I. Capacitor, a diode, and then the bias voltage. Oops. Such an ugly drawing. Anyway, so just imagine that this is the perfect drawing for this example. So during the positive, wherein V sub I is greater than V sub R, so we'll be having a closed circuit. Or, no. So let's start with this one first. So during V sub R, so this is our V sub R. So during V sub R is greater than V sub I, okay, we'll be having a closed loop here. So this one will be charged positively here, and then it will be discharged negatively. Okay. And then during V sub I is greater than V sub R, wherein this one now will become an open circuit. Okay. So this will be charged positively, and then it will be discharged negatively. So all of our voltages now will pass through this side because we now have an open circuit. Okay. So at that time, V sub O is equal to, so our VMC is positive minus the V sub I. So if that's the case, then if we have a higher V sub I, then it will become negative. Hmm. Positive, negative, positive, negative. Yeah, that's correct. And then we have an output of twice of the V sub M. This one is just lifted by our reference voltage. And this one is during the negative. So during the negative, yeah, that's correct. V sub O is V sub R, which is positive. So this one at this point. But during the positive half cycle, V sub I plus V sub R, why plus? So let me give. So just give me 1 minute to analyze why we have negative V sub I. Positive, negative. Yeah. So before this one is during V sub R, V sub I. EMC. So before or during the negative, it was charged. Wait. So during the negative to positive. So yes, it will be charged by V sub R, and then it will be charged by V sub I also. If we have a higher. And then during the positive half cycle, so during V sub R is greater than V sub I, capacitor is charged by V sub R. And so if that's the case, then VMC, so right, that's it for now. And then during V sub I, and then V sub R, so capacitor is now being discharged, but we'll have a positive and negative here. It will be charged positively and then it will be discharged negatively. And that is during at the point where in positive is greater than so if I will correct this uh, formula, VMC is equal to positive V sub R minus V sub I. I see. All right. So I just forgot that at this point, okay. So listen now. So are you guys there? Hello, guys. All right. So I just remember. Okay. So take a look on this one. So during the negative, it was now charged by the V sub I and then V sub R, right? Wherein we have this kind of equation. So VMC is equal to V sub I plus V sub R. So let's have an actual value for you to imagine. Oops. All right, so let's say we have a V sub I of 5 volts and then V sub R of say 1 volt, right? So during the negative half cycle, our VMC is now charged by V sub I and v sub R depending on their situation, right? So we've got this kind of equation. So V sub I plus V sub R, wherein V sub I is 5 volts plus V sub R is 1 volt, wherein we have 6 volts. And then during the positive half cycle, so as always, okay, as always, this one will become an open circuit. So why? That's because we now have a higher voltage here. So a higher DC voltage than this one. So if you're going to take a look on this one, our capacitor will always dominate the value of our reference voltage. Wherein, if you're going to take a look on this one during V sub I is equals to, let's say, 1 volt. So of course, this one is incrementing, right? Since this V sub I is an AC voltage. So 1 volt, 2 volts, 3 volts until it reach the maximum voltage. So during at this point, okay, we already have a VMC voltage from our capacitor, which is at a constant voltage of 6 volts. And of course, 6 volts is higher than 1 volt. So if that's the case, so this one will never have this kind of setup. So that is why I didn't include this one. Okay, so we only have, oops, during V sub I is greater than V sub R, wherein uh, V sub I is greater than V sub R. So if you're going to analyze this one, so V sub O is equal to the voltage from the negative half cycle, which is VMC, okay, minus our V sub I. Right, so positively charged and then it will charge negatively. So if you're going to analyze this one, VMC is V sub I plus V sub R. Why is it feels like I'm lacking something? So V sub I plus V sub R. But why do we have a positive sign here? So this will just be cancelled and then V sub O will become V sub R. During the negative, during the positive half cycle, hmm, 6 volts minus 6 volts plus 1. So during the negative, we have 1 volt. Uh, yeah, which is piece of bar. And then during the positive, we also have 1 volt. What are we missing? Can you guys, or do you guys also know what is wrong with this equation? So let's brainstorm why my equation is wrong. Because supposedly we have twice of the B sub n. So hindi po ba sapat same lang yung polarity ng capacitor sa V sub I at V sub R? Sapat or dapat? Hindi po ba dapat same lang yung polarity ng capacitor at V sub I at V sub R? Hindi. Positive to negative. Because during the positive half cycle, sige, tingnan natin. Because at this point, during the positive, right? So positive, negative. So during the positive half cycle, so let's say V sub I is already greater than V sub R. So it will be charged positively and then it will be discharged negatively.
Sir,
Yes?
sir, pag positive half cycle po nga ikot open circuit po kaya hindi magcha-charge.
Tama. At dito na madi-discharge. Oo nga, oo nga, oo nga, oo nga. Bakit nalimutan ko yung idea niyan? So good thinking. It is already charged during the negative half cycle. So that is why, if you're going to take a look on this one, we have a negative or whatever is the sign of this one. Yung kanina, yung VMC na na-calculate natin right here. So VMC is equal to V sub I plus B sub R. So that's the value of this one now. And then, as you can see, we have here a positive sign of V sub I. So if you're going to calculate this one, V sub O is equal to V sub I because we have a positive sign. And then whatever is the sign of this VMC. So that is why we have this one. Okay. So thank you very much, Mr. Louis Magilao. So napaka studious ng estudyanteng to. Oops, parang may natakpan. Baba ko lang to. Ayan. Okay. So thank you. Oo nga pala. Alright. So during the positive, as you can see, this one will not charge anymore because we have an open circuit. So positive is connected to the negative and the negative is connected to the positive. So this one is completely open. So just remove that one. So all of our voltages will pass through the load resistor. So whatever is the reading in this load resistor will be our reading in our V sub O. Alright, so again, I apologize for my drawing since I'm only using a mouse. So soon, we will upgrade our teaching method wherein I'll buy, or that one, like mga nag-drawing, ano gamit nila, parang drawing pad. I'm not sure what they call that one. But for now, just a mouse. Okay, so soon we'll be using a pad and then a pen. All right. So that's basically the idea of the positive clamper. Okay. So yeah, that's why we have this kind of equation. So V sub I plus the VMC, wherein VMC is V sub I plus V sub R. Okay. So is there still anyone who wasn't enlightened? Okay, with the explanation of Mr. Magilao. So this is a big credits for Mr. Magilao since he's the one who were able to solve this kind of problem or circumstances. So are we clear so far before we proceed to the next one or to the example of the positive clamper? with positive biasing voltage. So I think we should add this one. Is discharge and diode is open circuit. Okay, so I think we should interchange this one. Yeah, so diode will become open circuit, and then this open circuit, and capacitor is discharge, wherein VMC is equal to, wait, this one will not be charged because it will be discharged now. So V sub O is equal to V sub I plus VMC. Yeah, so that's the correct explanation on this one. So during the closed loop, it will be charged, and then during the open loop or open circuit, it will be discharged. Okay. So any concerns so far before we proceed to the next slide for clarification? Hello guys, you guys there? May mga katanungan ba tayo? So I'm waiting guys. So I'm assuming that you guys are brainstorming right now. Okay, that you are super focused on your screen wherein you're trying to analyze. All right, so I am now convinced that this is the correct equation for this one, or the correct assumption. Sure kayo Mr. Eda, Mr. Charles, and then Mr. Reister. Anyway, so if there's a part that you didn't understand, so you can always go back on this one. So this one now is very clear. Okay. All right. So moving on, let's have an actual example. Okay. So calculate the V out during the positive and negative cycle, wherein V sub I is equal to 5 volts, and then V sub R is equal to 2 volts. Okay. Okay. So uh, let's analyze this one step by step. So again, we always choose wherein we'll be having a closed loop because that's what we want. We want to charge the capacitor first. So what is that cycle? So that is only during the negative half cycle. So negative here and positive here. So negative is connected to the negative, and then positive is connected to the positive. So in that case, our capacitor now will be charged by V sub R and V sub I. So again, when will our capacitor will be charged by V sub R? That is only during V sub R is greater than V sub I. So this will be charged by V sub R. So this one now has a sign of positive and then negative. And then during V sub I is greater than V sub R. So diode now is closed circuit, and capacitor, this one is diode is closed circuit, negative to negative, yeah, closed circuit. That's right. And capacitor is charged by V sub I. Yeah, that's right. And then VMC now is equal to, so let me just remove this one, okay? To make it more simple, capacitor is charged by V sub I. Yeah, that's it. And then if you're going to take a look in this one, so we'll have this kind of equation. So VMC is equal to V sub I, because uh, this one is negatively charged, and then it will be discharged positively, okay, of V sub I. And then we already have this kind of setup before, wherein during V sub R is greater than V sub I. So before, this is already charged positively here, and then discharge negatively here. So they are contradicting. So what, or whoever has the higher voltage will dominate the other one. So in that case, we just have to deduct, okay, or yeah, deduct the lesser voltage, or actually not deduct. So in here, because they are colliding, wherein this one is charged positively and then discharging negatively, but our our current, okay, will go to our V sub O, okay, instead of going to V sub I. So if that's the case, then we have positive side here and the negative side here. So both of those voltages will add, or they now have the same sign of current, positive here, negative here. So same with V sub I, positive here and then negative here. So that is why we have positive V sub I and then positive V sub R. Right? So 5 plus 2 is equal to 7 volts. So we now have here a capacitor wherein it is charged by V sub R and then it is charged by V sub I. So uh, we were added. Okay. So 7 volts. And then V sub O is equal to V sub R. Why? Because we have a closed loop here, and then as you can see, the only voltage across our entire circuit is the V sub R, which is 2 volts. Okay. And then during the positive half cycle, so capacitor is discharged and diode is open circuit. And then this is already charged during the negative half cycle, so we don't have to charge this one now. And yeah, so it will only be added with our V sub I. So basically, uh, wait, yeah, so VMC is equal to, so the same, this one came from here. Okay, so this is not another calculation. So VMC came from our negative half cycle. So as you can see right here, V sub O now is positive V sub I. So why? Because uh, the sign up here, the sign of V sub I here is positive and then negative. So positive will go to our V sub O. Okay, and then VMC will also go to our V sub O, wherein it has a sign of positive. So V sub I plus VMC, wherein VMC is V sub I plus V sub R. So just put all of the uh, values. So V sub I is 5 volts, and then another 5 volts for V sub I, and then 2 volts for V sub R. So 5 plus 5 plus 2 is equal to 12 volts. Okay, so during the negative, we have 2 volts, and then during the positive, we have 12 volts. All right, so 2 volts, 7 volts, and then 12 volts. Okay, so any concern so far? Did you guys get this one by chance or no? Is this clear, guys, or not yet? Do you guys need more time to think whether this one is correct or no? So I'll wait for your confirmation that it's already clear. All right, so coming from Mr. Charles. So he said that is already clear to him, so that's good. All right, so what about the others? Are you guys still brainstorming, thinking, analyzing? So what, guys? So we now only have 1 minute and 40 seconds. So I hope during our break time. So we only have a break time of 5 minutes to 7 minutes. So use that time to analyze, okay, the part that uh, you were not able to understand at all. Okay, so kung may part kang na-miss or may hindi naintindihan sa last slide, so go back on that one and then reanalyze it again. And then if you're still confused, then that's the time that you can ask me. So I really hope so that you guys will ask. So it's actually more fun if you guys are asking because I can see that you guys really wanted to learn the concept of this topic about clumper, leaper, and so on and so forth. Okay. Mas maganda yung nagtatanong kaysa say, nagsosolo ka. Mas mahirap yun, di ba? So magtanong ka kung may mapagtatanungan ka. Pero kung wala, then so no choice ka, di ba? Pero kung meron naman, like what I always do, and that's I think na mas matututo kayo kasi nga mas maganda kapag live eh. Diba? Unlike kapag YouTube or yung video na pinapanood nyo, so hindi nyo na siya matatanong kung ano yung pinaliwanag niya doon, yun na yun. Unlike kapag live like this one, so that is the advantage of being present during the Zoom meeting. Okay? Kasi kapag absent ka at that meeting and then natapos na yun, so wala na. Okay? Kasi another topic na naman tayo.